Hi there again. So this video we are covering some fancy ways of counting that will make finding probabilities easier. So some of these you may have heard before, but there's three important definitions: factorial, permutation, and combination that we're going to cover. And all of these have formulas you can use on any calculator to solve. And so I'll show you how to do this as part of this video. So firstly, let's look at factorial. Factorial is a fancy way of saying, n factorial is a fancy way of saying, oh, I gotta turn off my screen here. Here we go. 5 factorial or 5 exclamation mark is a fancy way of saying 5 times 4 times 3 times 2 times 1. So this is what factorial is. Factorial. So this comes up if you're going to put things in a row. How many different ways could I line up 5 students in a row? 5 of us. So, well, there's 5 ways I could choose the first person. After I've chosen that first person, there's 4 students remaining. So there's 4 ways to choose the second. And there's, after that, 3 ways to choose the third. And 2 remaining students, like after I've chosen this person, I've chosen 3 people, so there's 2 remaining people to choose from the last one and 1 person. So this ends up being a fancy way to calculate that is 5 exclamation mark. So the way you can do that in Desmos is 5 exclamation mark. Notice that's the same thing as 5 times 4 times 3 times 2 times 1. Okay. So maybe you've seen that before. Quiz question. How many ways could you arrange a red ball, a blue ball, a green ball, and a yellow ball? So you got 4 balls here. How many ways could you put them in a line? Okay, so you'll probably see this as an application of factorial. Okay, so going on. Now, a very similar idea is how can I pick a subset of some set and put them in a row? So maybe I have a class of 20 people and I'm going to pick 3 people to come up and be a part of a demonstration. Okay, so there's 3 spots of the class. There's 20 ways I could pick the first student. But after I've picked that student, there's only 19 students remaining. So, there's 19 ways I could pick the second. Okay, we picked that student. After I picked that second student, now there's only 18 students remaining. So 20 times 19 times 18 is a way to pick a subset. So there's 3 from 20. A fancy way of writing this would be 20p3. From 20, I'm picking 3. And the P technically stands for a permutation. So this formula here shows one way you can calculate a permutation is n times n minus 1 times n minus 2 all the way down to n minus k plus 1. This just makes there be k different items. Notice there's 3 items I picked. But if I continue this process of multiplying by lesser numbers, I can get all the way down to 1, making this whole top of the fraction n factorial. And then what this term I added here is actually n minus k factorial. So that's a fancy way to calculate permutation. But you've seen probably that this might make more sense. But either way, to use a calculator to find this, you go into Desmos and say NPR, and then it's going to have you put n first, so 20, comma 3. So that's a pretty common counting term that we're going to use. So let's look at example. of, okay, you got 16 people on your board of directors for a committee, and you want to know how many ways can you pick a 4-person committee where there are titles. So if there's titles, that means it's kind of like putting them in a row where they matter. So the president would be first, vice president second, secretary third, and then treasury last. Okay, so to pick the president first, there'd be 16. And then to pick the vice president, 15, and so on. And notice it doesn't matter the order I do this. If I were to multiply these all out, it's the same thing as saying, well, maybe I'm going to pick the secretary first, 16, and then maybe the vice president, 15, and then the president, 14, and then the secretary. Well, it's all the same numbers multiplied together, and you can rearrange it and see that it's going to give you the same number. So way to calculate this, again, using Desmos, would be, well, you could say 16 times 15 times 14 times 13, or you could say NPR of 16 people total, but I'm choosing 4, 16 comma 4. How many ways do I choose 4 people where the order matters from a group of 16? Okay, so that's permutations. Okay, so what's the difference between a permutation and a combination? The last definition. Well, if I'm picking where I don't care about the position, I got a 16-person committee or 16-person board, and I just want to pick 4 people. Order doesn't matter. I don't care if there's a president, vice president, secretary, or treasurer. I just want a group of 4 people. Well, we can use the same work we did. We could pick our 4 people with order, but then realize I could rearrange these any way, it doesn't matter. So once I've picked my 4 people, how many different ways could I put them in a row of 4? So with 4 members selected from above, well, there's 4 ways I could have put the president, 3 ways I could have put the vice president, 2 ways I could have put the secretary, and then the remaining person would have gone to the treasury. So this shows us if order doesn't matter, I've overcounted by this much. So what we got to do is take our answer from before and divide by 4 factorial. So of these 43,680, I've overcounted by a factor of, it looks like this number would be 12. Okay. So a simpler way of thinking of this is I just want to know how many ways can I choose K items from N choices where the order doesn't matter anymore. I don't care about putting them in a row. This is called a combination in CR. And just like before, we use the formula for this takes the permutations and divides by K factorial, the number of items I selected. And so this formula is also called in choose K. You can also calculate it in Desmos like this. And CR, instead of K, it uses R. And we would say 16, comma 4. How many ways can I choose 4 people from a 16 committee where the order does not matter? So 1,820. Okay, so there's some other codes. Like this is a programming language called R, and that's the code for finding the same thing. So let's look at another example. You got 4 students to be chosen from a 35-member class to represent a student council. How many ways could you do this? Okay. This is a combination. Notice the order doesn't matter. There's no student council might not have no position titles. So order doesn't matter. So it'd be 35, choose 4. So see if you can practice calculating that, preferably using an online calculator. But if you're mathematically inclined, you can also write this out using the formulas above. Okay, so there is our definitions. We're going to use these in some interesting examples going forward. All right, so I'll see you in the next video.